All right, guys, today we got the law of sines. Law of sines is a way to find parts of triangles that are not right triangles. A triangle that's not right is actually called oblique. So any kind of triangle that is oblique or not right, you can use law of sines. Well, not any kind, but a bunch of them. You can use law of sines to solve different parts that you're missing. All right, the law of sines works like this. And you probably saw this in Algebra 2. Most of you, I'm sure, did, or geometry. Basically, you can take the sine of an angle, if it's angle A, and put it over to the side opposite that angle, and that's going to equal the sine of another angle over the side opposite that angle. So these side A and angle A are opposites of each other. Angle B, side B are opposites. Sine C, side C opposites. They all three ratios have to be the same. You can also turn them upside down. You can put the side on the top and the angle on the bottom. It will not matter. But that's the law of sines. So make sure you get that down somewhere. You can use law of sines in situations where you have, and you got to remember this from geometry. ASA stands for angle side angle, meaning the angle is included. Sorry, the side is included in between the two angles. Side angle angle, or angle angle side, or side side angle. And if you look at that backwards, oh, don't look at that backwards. But anyway, ASA, SAA, or SSA, or when we can use law of sines. Bottom line is, you have to have a side and an angle that are opposite of each other, that are across from each other. Let me show you an example here. This one, if you look at angle C, which is right here, which we know is 25, and side C, which is right here, is 80.4. They're opposite of each other. That's what we need. You have to have at least one pair of that before you can do law of sines. So to find the rest of the stuff, we're going to say sine of the angle, sine of 25, over little c, which is 80.4, and that's going to equal, okay, that we know angle A, sine of angle A, sine of 20, which is angle A, over little a. And I'm not going to show you my work here. I'm just going to show you the final answer that I get when I work this out. But what I'm going to do is I'm going to cross multiply this way and that way. And then I'm just going to solve what I have. Well, let's do that. If I cross multiply, I get this. I get A sine 25 equals 80.4 times sine 20. Now this side, I'd go ahead and multiply that out. Then I'm going to divide that by the sine 25. So if I divide that by sine 25, that will tell me what my A is. So I'm going to punch that in real quick. And I'm getting A is 65.1. All right, so that's my A. Now, I still need to find big B and little b. Now, big B is easy to find because I know the other two angles. Remember, there's 180 degrees in a triangle, so I can do 180 minus 20 minus 25, and whatever's left is going to be my angle B. So angle B is 135 right there. And then once I know angle B, and I still have this ratio, I have my C's, I can say sine of 25 again, like I did a second ago, over 80.4. Those are my two C's, equals sine of 135 over little b. That's not very good, 135. That's 135. I'm going to ruin my iPad. Okay, same deal. Cross, multiply, divide. You're going to end up finding out that little b, or side b, is 134.5. So there's your three answers. That's how law of sines works. Not a hard process at all, but that's how it works. And I'm going to show you one more case here. This is a picture of a triangle. In this case right here, this is an ASA case. The last one I showed you was an SAA. This one is an ASA. But it doesn't look like at first that you know what you need to have. But I actually can find out angle C. I'm going to do 180 minus 75 minus 60, punching that in. What's left is this angle up here is 45 degrees. Angle C is 45. And I know side C down there is 340, so I'm going to start the same way. I'm going sine of 45 degrees over 340. Those are my two C's. And I'm going to say sine of big A, or sine of angle A, 75 over little a, side A. And do the same thing on cross multiplying and working it out. And I'll let you do that on your calculator. And to find side B, save a little bit of time here, do the same thing. Sine 45 over 340, except this time I'm going sine 60 over little b. What happened with my fraction bar right there? Over little b, or side b. And when you cross multiply right there, divide for b, you're going to get about 416. So it's about 416 miles from Los Angeles to that satellite right there. From Phoenix would be whatever A was, and to be honest, I didn't punch that one in. So there you go. Right now, yeah, law of science, good stuff. All right, one negative to the law of science is the SSA case. I shouldn't say this on video, but sometimes this one could be the pain in the angle side, if you know what I mean. Okay, so watch carefully. If you have two sides and the angle, three things could happen. And here's the deal. Side A, look at this one right here. Side A could be smaller than the height. And if side A is actually smaller than the height, when you try to find the triangle, it doesn't even touch the third side, which means there's no solution. So sometimes when you have SSA, and you only have to do this when you got SSA, by the way, you're going to get no solution. That's possible. All right. The other case is your side A, right here, the red side, is exactly the same as the height is, which means it can just touch that third side in one point right there, which means you're going to get one answer or one solution. All right. And the third case is the most unusual case, and that is, what if angle A is bigger than the height, right? But it's also smaller than B. And if that happens, then what's going to happen is it can touch it there or it can touch it there. Okay, you can see where they kind of swung. I don't know if you see that little arc down here. What they basically did is they took side A right there and kind of swung it back and forth, and it hit that side twice. So there could be two solutions. Okay, so the ambiguous case, you could get no solution, one solution, or two solutions. You got to really be careful. Now I've got two more slides here. I'm going to show you two of the cases and see if I can make some sense to you. All right, here's the first one. They're going to give you information like this. They're going to give you all this information like angle A is 45, side A is 7 on the square root of 2, side B is 7. And I drew a little rough sketch down here. Well, I actually copied the picture, but if you look at it, that's side angle, or angle side. So it's ambiguous, which means it could be two cases, one case, or none. Anytime they give you one of these, you need to find the height first. Write this down, please. The way you find the height is you always do B sine A. That will always tell you what the height of the triangle is. So B is 7, angle A is 45 degrees. If you punch that in your calculator, 7 times sine 45, you're going to get like 4.9, almost 5. So the height, if I do the height straight down here, that's 4.9. Here's what I know. 7, that's this side right here, that's 7 on the square root of 2, is bigger than 4.9, which means if I wrote it straight down, it would come down here, and if I swung it, it would hit like right there. Now 7 on the square root of 2 is bigger than that side, is bigger than 7. So if I swung it the other way, it would hit way out here, which means it can't hit twice, because the side 7 stops right there, which tells me there's one case. There's one case when when side A is bigger than the height and also bigger than that side over there. There's just going to be one solution there. All right, so let's just go ahead and solve it like we did a minute ago. I'm saying sine 45 over side A is sine B over side B, which is 7. Now, to solve for big B this time, you got to cross multiply. You have to end up using inverse sine. We'll work on the calculator stuff tomorrow in class. We have to use inverse sine. And for big B, we are getting 45. We're not getting 45. We're getting 30 degrees. Okay, we're getting 30 when I punch all that in. Now, because that one's 30, and I already know angle A is 45, automatically I know angle C has got to be 105, because that's what's left over out of 180. And then to find little c, I'm going to use the same thing I started with, sine 45 degrees over 7 square root of 2 equals sine 105 over side C. Again, cross multiply, do your math, you're going to find out C is 13.5. And kind of double check here and make sure that the smallest sides opposite the smallest angle, biggest sides opposite the biggest angle, all that kind of stuff. Let me show you one more case. Okay, again, they're going to give you the info, angle A, and side B, and they're going to want you to see what happens here. I went ahead and drew like I didn't draw, I copied it, okay, but that's a picture of what this could possibly look like. Not sure how many solutions there are yet, so I'm going to find the height like we did last time. So to find the height, I'm doing B sine A. If I do B sine, I don't know why I just didn't put 122 there. So I'm doing 122 times sine 42 degrees. I'm going to punch that in real quick. And I get 81.6. So 81.6 is height. So if I go from here and I go straight down to the third side, straight down right there. That's how you do height, by the way. It's 81.6. Now here's the problem. That side's just 70. A is just 70, which means if I went straight down from C up there and went straight down 70, I would only get to about right here. Especially, I cannot go slanted that way and hit that. There's no way I can go and hit 70 and hit that third side. Therefore, that's a no solution case. There's no way. Anytime side A is less than the height that you found, no solution. Can't do it. And here's the deal about no solution cases. Even if you try to do this, if you set this up and started working it all out, like we've been doing, like this, your calculator is going to give you an error. It's not even going to let you finish because it'll say domain error, stuff like that. Now, there's one more case I didn't show you, and that's if there's two cases, but that's a lot easier to show it to you in person than it is to do it on this video. So I'm going to wait and show that to you in class tomorrow, the two-case situation, and pretty ambiguous. So this video is kind of weird. I feel like it started really easy. Law of sines is not hard at all to do, but that one case, when you have SSA, it could be a pain in the angle side. You got to just kind of go with a little bit. We'll work on that quite a bit tomorrow. All right, I'll see you then.